So another very unique aspect of how ThreeFold has innovated to run applications is the fact that we use a very different methodology to run applications on these zero nodes than the standard way. And the standard way, let's just go over that very quickly. The standard way of running an application is to go to a certain machine, whether it's physical or whether it's something connected over the network. We go there, we download the software in some shape or form, we then install the software on that particular server, and then we run the software. Now think about what that does. So what that does is, if you want to run that same piece of software on, let's say, 100 different servers, and that might sound like something which is an odd use case, but it's not, because for very large websites, for example, they scale by having multiple web services, the same content. So they have got like 80 or 100 web servers running, actually doing exactly the same thing. But by doing it in the way I just described, you have to install it 100 times. You have to maintain it 100 times. And every update, every security fix, every bug that gets fixed and needs to be installed, you need to install 100 times. And I know there's certain automation frameworks out there that do that for you, but it's still a footprint of 100 installations which needs to be considered, which needs to be thought of. And the risk is there that someone forgets. An engineer doesn't update a system. An engineer just updates 90 out of those 100, which leaves 10 of those installations still vulnerable for the flaw, for the bug, for maybe the attack vector. So that's not a scalable way, and that adds complexity, it adds work, and in the end it adds costs. So where we came from is the fact that we don't want to install software. We want to run software, but not install. And taking that very different approach means that you have to, when you run the software, also distribute the software, because it still needs to get the same files, it still needs to get the same binaries to run that application, and the same configuration files to actually configure the application. So we have devised a very smart methodology where the files that need to be run are stored in a location, either private to an enterprise wanting to use the grid, or public from a developer that wants to share out its resources and its application that he has built. But it's coming from a location where it is stored one time, and then 0S, if and when it gets the instruction to start a container, which is a primitive, and run a certain application in that container, it will fetch in a very smart way that particular application with all of the needed files from that hub, from that central location. And again, it's not a central location, one for the grid, it's one for everyone that wants to have it. So you can have still 1,000 of those, and they can be private to organizations or public and shared, like I said earlier. That is what we call an F-list, a file list in the end, put together as an F-list. And we can do that even for very large files or very large applications in a very fast way. Because what we have done in this hub, we separate metadata, a description of what files are in the particular image and what the actual data is, and the files that are in the image with all of its location, properties, ownership, rights, what have you, is metadata, which is a fraction, less than 5% of what that particular image is. And then you've got all the binaries, the applications that you need to run, which are stored there as well. Now, when the container or when the 0S gets the instruction to start an application, it will only download, to understand what files are available and what it needs to do, that metadata. Again, like I said, only 5% of the total image size. And then step by step, because applications are just a sequence of binaries of applications starting one after another, it will download the necessary binaries, the necessary files, one after another to bootstrap, to start that application. If certain files or data parts or config files that are in that image that are not available to start up the application, but maybe at a later stage when it's operational and when something happens, then it's not part of that whole download at the boot process. Which means that the boot process in essence is almost as fast as doing it from a local disk. And it doesn't install and leave any files, any footprint to maintain on that local node, on that local server. Which means that you can have this same setup with 100 servers running that particular web server image, but there's only one image to maintain, update, and keep bug-free, which is a really, really cool step forward and making it easy to do so.